Right. Okay. So welcome everyone to second session of our stream today. We've got measuring zOS from Danilo. Danilo, are you happy to take questions at any point during the session, or would you prefer people to wait until the end?
Well, I think well, we are doing live. It's not a recorded session, so if there are questions, I will try to answer them when they will come forward.
Okay. So if at any point anyone has any questions, please just post them in the chat, and we will get them to Danilo and get them answered. So everyone is out of the waiting room and in. I'll hand it over to you, Danilo.
Okay, so first of all, the right title of the paper is Measuring zOS Connect, which is a specific component. My name is Danilo Gipponi. I work in IPv Technologies, which this year is 20 years on the market. So we are also becoming old as a company. Anyway, this is the agenda of this paper today. We will have a short introduction, then an architecture overview of zOS Connect, and then measuring zOS Connect from outside and measuring from inside. So let's go to the introduction. Cloud and mobile application built on RESTful APIs that use JSON message formats are predominant standards for the new application development. What I mean is that almost all of the app on your cellular phones and things like that are written using this kind of format. It is the standard at this point in time. And IBM came up with zOS Connect. zOS Connect Enterprise Edition. With that, IBM provides a framework that enable zOS-based programs and data to play a fundamental role in an enterprise hybrid cloud strategy. So I just read the sentence, and what does it mean is really something that allow the mainframe, so everything that is loaded up and running on the mainframe, to provide information to your app on your mobile phones using this zOS Connect. We will see in a while how this is happening. In practical terms, what happens is that application and subsystems such as KIX, IMS, MQ, and DB2 can be exposed as RESTful APIs. So it's a sort of an adapter that will make translation from the zOS language to the application language on your mobile phone and vice versa. So what's the advantage of that is that the developers can develop interesting application without really any need to understand zOS and the subsystem on zOS. So someone that doesn't know how KIX is working still could rely on data provided by KIX using this interface. And as I said, this is going back and forth, so it can work in the same time also in the other way. If you want, if you are interested in that, there is a white paper, so a PDF, or if you prefer, a Word document that explains everything that is going to be said in this presentation. So if you are missing anything, you have the slide. And if you want more details, then there is a white paper available. And you can get to that either to this email address or eventually through Share UK. Okay, let's start with an overview of the architecture. zOS Connect is built on a WebSphere application server for zOS Liberty profile. And it's important to note that the installation of Liberty, which is included with zOS Connect, is dedicated to run zOS Connect servers, and full stop. It's just something specific for that. How does that work? If you install that, you then will start to different started task. One will contain the server process, and this is a Java virtual machine that run physically the Liberty code. And then there is another process or another started task, which is called the Angel process. And this is the one that provides the facility to the server process to load the data and make the communication happening. So again, in order for this to work, you have to have two started tasks running on the mainframe. You see in this screenshot and as DSF display, and you see that here we have the first address space that is called zOS Angel or AGL, and the second one is the server. Okay, this is taken from the IBM documentation, and this is what is going to happen. You have someone, let's say these people on the left, this design of a guy on the left that will access through his mobile device or his, I don't know, computer or laptop, whatever, using whatever meaning and whatever application that can connect to the mainframe through RESTful APIs. So the request will be sent, the zOS Connect will take it and provide all relevant services within the orange box. So this box, on the first box on the left. And as a result, there will be a request to the zOS address space, which could be, as we said before, a Kix application, for example. And this will come back with an answer that through, again, these two address spaces will be then provided back to the requester. So it's a very simple schema. And this is the other way around. Again, it's taken from the IBM manual. And so your application can be designed in a way that eventually, based on your request, there will be some other question asked to you from the mainframe. But then again, who is going to develop the application doesn't really need to know anything about what is running on the mainframe. Okay, this is a very short and quick description of what it does. It's very simple logically, so it's not that complex. And now the focus of the paper is how to measure this zOS Connect activity on the mainframe. So the first chapter is measuring zOS Connect from outside. Okay, the first thing you can do very easily is to take the SMF record 30, so the started task activity as an address space. And with that, you may see the consumption. This is some data taken from a test we did in a test environment. And you may see that almost all of the consumption is running on special engine. So it's also very good from the software cost point of view. And of course, because this is a standard record 30, you have other information about the zip eligible time spent on CPU, paging activity, disk I/O activity, the usual kind of stuff. The problem, as usual, is that when you just take the record 30, you see the address space as a black box. So you don't really know what is happening inside. You see how much CPU it is consuming, how much IOs, how the critical resources are used, but you cannot understand exactly what's happening inside. And the worst is the fact that you do not have any information about the performance of this, let me call it adapter. So you just make a request to zOS Connect. You get some feedback. How much is it going to last, this request? You have no clue when you look at the record 30. These issues can be addressed but you have to make some workload manager customization, and then you will collect the data in through RMF and through workload manager in the record type 72 of SMF. To do that, you need to have at least 2 workload manager classification rules. And in the next few slides, we are going to cover what these classifications are. So they have to associate the server address space and API request with separate service classes and appropriate different performance goals. So one is for the server and the other one is for the angel. In addition, if you want, you may add service and report class to measure resource consumption and performance of the 2 components. Okay, so here you see the panel where of the workload manager where you may define, and now you see that we have the zOS CAS object. That's the name of the started task that we are going to run. And we see here that the service class is sysstc, but there is a report class added to that, which is zOS CAS. Now we are going to change that, and as a service class, we create, in this example, you may choose the name that better suits your needs. So this is, you see the description is a component broker address space, and we assign to it the service class zOS C API and the report class that we use RCB in this example. At this point, you may measure and produce reports about the consumption used by the service class and by the API. You may do that using the report class. So you know exactly how much CPU with the report class. You may see which part is dedicated to the server and which part to the API. The same is true with the zip consumption, so you may analyze in great detail both the general purpose CPU consumption, which is the one very expensive in terms of cost of software, and also the zip part of it. This is standard report activity. In this other example, we see using the information that are provided by SMF record 72, we may say the number of transactions executed, which is represented here by the blue bars, and you see the average elapsed time. So let's say compared to before, you have now much more information. The first note on this slide tells you that when we look at the previous graph, the graph of the previous page, it's important to understand that the elapsed time is really the elapsed time of the request from the moment where the zOS connect is invoked to the moment that an answer comes back from KIX or IMS. The other interesting information that are provided by SMF record 72, like memory utilization, I/O activity, and the workload manager delays are also there at this point for you to analyze. So if there are any issues, you may also have information about how much memory you are using if you have problem with the I/O or some delays. Something more you can do if you do some other customization. You may assign a transaction class to the APIs, and at this point you will have more information. Okay, here you see what you have to customize. So this is the XML file that you have to modify, and this is an example of what you have to write inside. So first of all, workload manager feature should be enabled. Then you have to specify the host, the port, the method, and the resource that can be used to assign a transaction, specific transaction, to this kind of request. In this example, there are two classes defined, tkick enqueue and tkick ord, and you see the definition. So this is the transaction class, tkick enqueue in the middle of the page, and soon after that there are the orders. So we have identified the two different type of, let's say, request objects. At this point, when you have defined them, you can assign those transaction classes in your workload manager definition. And at this point, you can specify specific importance and goal to get measurements for the workloads, and to tell them, or better, to tell workload manager how critical this kind of service is in your eyes. So at this point, we see measuring zOS Connect from inside. And what does that mean? It means that zOS Connect can be configured to write a specific SMF record. This SMF record is the 123, and this will provide you more information about individual API provider, API requester, and administration requests. So just to make an example, it's just an example, but the idea is that what we saw before is the customization of the workload manager. So you get the information from the workload manager. Something similar you can do with Kix, for example. But Kix provide also the record 110, where you have a lot of details. A similar thing is true with zOS Connect, where you have an SMF record type 123 that you may decide to write down. And if you do, then you will have additional information. Now, the first version of this record, version 1, provide only basic information. So it's not very much detailed, and let's say it was not much useful. But then a version 2 has been introduced, which supersedes version 1 and contains much more information. Be aware that by default, if you do nothing, if you just activate the writing of this record, zOS Connect will write the version 1. And as I said just 2 lines before, that is not the one that we are really looking forward to analyze. So you have to do something in order to write version 2. We will see in the next slide what you have to do. And going forward, all the results and reports provided will be done analyzing the version 2, which is the one that contains some meaningful information. Okay, the SMF 123 records are written by using the audit interceptor. And that is an exit program included by zOS Connect. The interceptor definition need to be included in the server XML files. Now you see that the third line of this XML file say SMF version equal to. This is, and the AP provider SMF version 2. This is the one thing that you have to make sure you do. Otherwise, those information that we are going to analyze in the next, in the following part of the paper, they will not be produced. There will not be that kind of information. So very important that you tell the product to use the SMF version 2 with this customization. Okay, once you have defined the fact that the version 2 must be used, the SMF 123 will have two subtypes. The first one contains detailed information about API provider requests. And the subtype 2 instead contains detailed information about the request made by the requester, including information about the endpoint, the HTTP endpoint that will be served by the zOS Connect. Again, going forward in this paper, we will see some graph based only on the first part. And this is a real production data, but we masked that for privacy reasons. So the names and the, let's say, they are not the real names, just to avoid to give up the customer name. But this is real data. These are the most relevant fields that you find in the SMF record 123, and that allow you to identify the Connect server. You have the sysplex, the system, the version of the server, the address space name, and on the left you see the, let's say, the SMF manual or field that is written in SMF. So we have the name of the address space, and the JS number, and the path where is located the server XML file. Sorry, I will go back just again on the previous slide. This is, these fields are, let's say, important for you to identify the Connect server you are analyzing. So with this information, you know exactly what server you are analyzing. With these other fields, you can identify the type of request. So, and the fields are request type that can be 0, and that means it's unknown, it's not understood by the system. 1 is an API, 2 is a service, and 3 is an administration request. Then you see the method, and this field may contain the get, post, put, or delete statements. Then the name of the API, the version, the service name, and the service version. So in this graph, we see the total number of requests per API and hour between 7 and 12. And you see that we have divided, according to our definition, different type of API. Let's say, if you are using zOS Connect, then it's really useful to do this kind of activity because you will understand exactly what kind of requests are arriving to the zOS Connect and where they will be transferred. Okay, going forward, we see the definition of the fields that allow to identify the client which is requesting, making the request, and SOR providing the API. So you see again the definition of the fields. You have the IP address of the client, the service provider name, and then the system of record identifier, system of record resource, and the reference to element in the XML file that identify the connection to the system of the record. Again, an example of the kind of graph that you can produce afterwards. So you see the number of requests, and you may divide them by the client IP address. So probably the Unix server or whatever Linux server that is collecting the information and is talking to you. Or anyway, these are fields that will be written down by SMF, and they are supposed to be meaningful for you afterwards. As I said, here they are masked for privacy reasons, but it's important that you know exactly where the requests are coming from. Then you have, or you may collect information about successful and unsuccessful requests. So you have the response code and response flag. And here it's important to know that if this bit is 0, it means that the request has been timed out. In the example that we are going to show on the next page, we had 3 timeout requests, 8 requests ending with a 500 HTTP response code, and just one request ended with a 400 response code. Okay, that is not represented, but it's just to give you the information that you may have there. Then there are also some timestamps that are written in this 123 record, and these timestamps may be used to analyze the time that is being used moving through one section of the adapter to the other. So you have the timestamp when the request was received by the Connect server, the timestamp when the same request was sent to the by zOS Connect to the SOR. Then you have the timestamp when this was received by the SOR, which is the other, let's say the Angel address space, and then finally the response sent to the requester. So the first and the last timestamp, if you subtract them, you will know exactly the elapsed for this request. So from the moment when it arrived to the moment when it was answered back. And in between, you have some split. So if there is some anomaly and you need to understand where the time was spent, you may use those timestamps to understand it. Okay, so in this example, we calculated 4 times T1, T2, T3, T4. And so the first one is the latency before sending the request to the SOR, then the time spent in the SOR, then the latency in zConnect before sending the response to the requester, and finally the elapsed time of the request from the moment when it was received to the moment when it was sent back. Again, these may be useful if there are issues or to understand if everything is working as expected. Okay, this is just an example. And again, at this point, what we have done is that we have split the average elapsed time by API. So again, to see if there are difference. And again, if there are difference, you then may understand where do you spend that elapsed time. So probably some of these requests are more heavy in terms of information provided back. Okay, this is another example. Here, these are just examples. So the point is when you do the analysis, it's important to have this information and then you may see. And generally what is interesting is to track the behavior in time. So if there are, and when there are anomalies, you spot it on at the first glance.
Danilo, sorry, before you move on to this slide, we've had a question from Dave.
Yes.
David has asked, is there information about body and header in SMF123?
Oh, well, I can't answer by memory. I don't think so, but I have to check about that. Anyway, the SMF record 123 is documented, but those, let's say, those that I am presenting here are the fields that we are used in a production environment to analyze the activity, which doesn't mean that, let's say, that there will be for sure something behind the request of the, let's say, what I can do is I can have a check afterwards. If you, Nathan, can please find a way to forward me the question, I will answer to that through email.
Okay, I will do. Thank you, David.
Sorry, David, the answer is not, but by memory, I can't remember. I don't know.
I'll let you carry on now, Danilo.
Okay. Well, then the things, the presentation goes forward with other fields that we used in our example, in our situation, and is the length in bytes and the length in bytes of the response. So how long was the request and how long was big the response back. There are other information and other timestamps, and maybe really looking at with some detail, yeah, maybe the information that Dave was requesting is available. Yeah, I should have a check. I will do that afterwards. So the flow of requests may be different. The point is, you may have requests that goes to different in different places. So the course of the flow may be interesting to understand in order to understand if there are different in elapsed time. Again, whether that could be related to a different kind of subsystem that is receiving the request or that kind of information. Now, if you're, let's say, if you are moving in an enterprise hybrid cloud strategy, which is something that IBM is pushing somewhat with their marketing messages, the latest marketing message they provided when they presented the last hardware, the Z16 family. So the expectation is that this is still something somewhat in a niche. So it's not something wide used by every other company. But I would expect banks and or those companies that use mobile application or that kind of application in order to do real business, and they have as a, let's say, all the data and the relevant information relies on zOS technology, then for sure zOS Connect will be a must. So I expect this to become more and more interesting in the coming years. This presentation is just focused on the measurement needed to control application to exploit APIs and service provided by zOS Connect. Again, if you exploit the traditional SMF records, that is not something that you should not have a look at. So it's, let's say, again, the example that comes to mind to me is the kicks. It's like with kicks. So it's important to know what's happening inside the subsystem using the 110, but also the record 30 and the record 72 provide a lot of important information. So you should do and treat everything as in the old way. For sure, if you are going in this direction, you should exploit the record 123. Okay, and that is it. Again, let's say that it's important for me. If you are really interested in this area, please request for the white paper. That is much detailed. It's written down, so all the information is there. And if still afterwards you have questions, feel free to forward them to EPV and or to me or through share, and we will reply to them.
We've had a question, Danilo, asking where we can get a copy of the presentation.
Let's say I will go back in the slide where I gave one way to get to it. Again, if you download the slides from the Share UK website, you will have this. That there it was. Anyway, let's say the very simple way is to write an email to this email address and just write something like, I just saw the Share UK presentation. I am interested in the paper measuring zOS Connect. And we will reply straightforward, sending it back.
And also,
probably is the easiest way.
I've also posted my email address in the chat there so everyone can take a copy of it. So if anyone would like a copy of the slides, they can email me and I can arrange Danilo to send you a copy, or you can email Danilo directly at the email.
No, let's say that the slides that I used for this presentation are there available on the UK Share, so you should be able to get them straightforward from the UK Share website. The white paper is not there. If you want the white paper, so a Word document or a PDF document that contains the detailed description of all the steps that you have to do, then you write to this email address, or to you, Nathan, that's fine. You may act as a server in this case. So you will get the request and you will forward that to me. That's fine.
Okay, and we've had a question from Martin. In SMF30, is there a valid way to tell a zOS Connect address space other than usage data section product ID of 5655 CE3 or 5655 CE5? Just looks like a Unix address space to me.
Let's say that when you look at the SMF30, you really find it out using the name of the address space. So it's really the best way to identify the zOS Connect address space and then the activity related to that. So if you could, let's say you may decide there are some rules, but then and some part of it, it's free to your fantasy to define the names of the of these two address space that 2 by 2 are representing a zOS Connect server and angel. You must know the name of this server and angel, and with that name, just collecting the SMF30, then you can spot and analyze the address space that you want to.
Martin's also said, yes, but you don't know what it should be called.
I'm not sure what it means by that. So it doesn't know the name of the server. Is this what it means? Because on the record 30, you just see the activity of the address space that is running and is providing the service. It's like, I don't know, the DB2 dist address space, for example. So it's an address space that gets the information from the distributed system and then exploit them in DB2 through the RDA or whatever means. And the point is, when you look at the SMF30 record, you just get to that information using the name of the address space. So you should know the name of the address space in order to exploit the SMF record 30.
Martin said the customer and installation might know, but you and he don't necessarily. Martin, if you'd like, I could unmute you, Martin. If you'd like to speak to Danilo directly. Said yes, please. Right.
Hello, Danilo. I wasn't trying to make trouble. I mean, I've actually just gone down this road myself, and the product ID is there for not the Angel, but the main address space. And the thing is, you and I, when we see data from customers, and I'm going to make the claim in my next presentation, even customers themselves don't necessarily know what's going on the systems. So knowing the names is nice. I just thought you might have a trick that I was missing in terms of actually
understanding from the record 30. Well, let's say probably the point is, hello, Martin, I didn't realize it was used in the first place. So now that I hear you, how's life? Sorry for this short. No, the point is, I'm sure maybe as a quick answer to your request, I don't know the program name. That could be if the program name is a specific one, but I didn't.
Well, here's the bad news, Danilo. It and everybody else. It's BPX BAT SL, which is pretty darn generic, right? And that's why I'm looking for something better. The usage data section does have these two product IDs for version 3. One of them is the CE5 one is actually called Universal, and I have no idea what that means because guess what? I don't really know zOS Connect terribly well. But somebody could put it on your beloved system and not tell you they've done it, and you'd quite like to stumble over the fact in a scientific way. That's the motivation behind my line of questioning here.
No, I understand, and I don't have a straight
you don't
answer.
have a better answer. Okay, no, that's fine. If you had, I'd take it, mate, very happily.
Again, the point is, so far we haven't. It's something that I would expect it will be heavily used in the future. It's a sort of slowly crawling, trying to enter in this. But
Yes.
it's like the component broker is not something that it was heavily used before. So the point is, those that already use it, then it's easy for them to start, and definitely it's very convenient. And for the other, it takes a little more time, but it will come. It will come because it's very, very nice.
You've just said something triggering here. So you said component broker. It's interesting. The customer whose data I have where I spotted this product ID, they don't actually have any component broker rules that in any way relate to zOS Connect. So I think probably they should, if they can only figure out what they want them to. You raised a good point by mentioning component broker being a pretty rare thing to see.
It's the WebSphere in the first place. So it's because we are supposed to be dinosaurs. That's the first name that was given to this T-Rex, and that is the name that we use.
Yes.
But it's so what I really meant is the fact that not everybody was using WebSphere on the mainframe. Not all of them, and those that do, then for them it's an easier path to go in this direction. And for the other, I believe they will go in that direction, but it will take some more time because they have to activate this kind of technology. That's my feeling anyway. That's not a statement out of God. I think
you're right. So do you want to see if some real customer actually has a question other than just nuisance person me? I'll go on mute again.
Anyway, we are, you know us, we are, I don't know if we are small or big. Amongst our customers, we have 3 or 4 companies that exploited this thing. So it's not so wide again, but there are companies that are interested. And then again, my feeling is that it will become popular.
Does anyone have any other questions for Danilo? And thank you, Martin, for coming online and speaking directly to him. We've not had any more questions come through since Martin, so I think perhaps we'll start to wrap it up there. Danilo, thank you for your session.
Thank you all, and ciao again, Martin. It's been a pleasure hearing from you, and maybe hopefully we will meet again sometime in the future in real life and not in these virtual rooms.
But hopefully in November we'll be doing the next face-to-face conference.
Yeah, but
and
we are trying in EPV, we are trying to do real events, and it's very hard, it's very tough. I don't know, UK has always been different, and in that respect, UK share has always been much more populated than any other around in Europe. But still, what we see right now is that companies, let's say, tasted the value of not sending people away in terms of costs. And now it's very, I see it's very difficult to get approval from management to do education, to do traveling. So I'm curious to see what will happen in November. Well, we will be in contact anyway.
yes, and so Mike and Martin have thanked you for the presentation. As I mentioned earlier, if you'd like slides, you can get them from the GSE website, or you can email me or email Danilo. Our next session for this stream is at 12, so hopefully I will see you all there. And thank you, everyone. And thank you again, Danilo.
Thank you. Bye.
Bye, everyone.